Welcome to Brain Vision.
Once again, welcome to a new problem. This time we have a spring, and the spring is being stretched in opposite directions with the force. Remember, each time you stretch a string, there's always some kind of internal resistance against the stretching. And that the force that resists the stretching follows Hooke's law, meaning that the direction of displacement, if you're going this way in x, then the force is gonna oppose the force opposing that motion will be negative. So that's according to Hooke's law. Okay, that's according to Hooke's law. So one of the things that happens is that in this new problem, the were given certain dimensions, and the length of the spring, the unstretched length of the spring, happens to be 0.240. So the length is 0.240, and then there are two forces moving in opposite directions, and they increase to 15 newtons. So the forces increase to 15 newtons. So we want to find out, when you stretch the spring, how long is it going to be, and also and how much work. So we're looking for x, the distance it stretches, and we're also looking for the work done in stretching the spring. In this case, we're going to use Hooke's law. So F equals to negative kx. That's the force required. We're looking for x in this case. Divide both sides by negative k. X happens to be the stretching distance that we're looking for. So F over negative k. The force is 15. Remember, it's a negative force because it's stretching in the opposite direction. So we're going to have negative 15 n. That's our force. This 15 newtons is negative. And then the spring constant K happens to be 300 Newton meters. That's the string constant. If you divide those two numbers, you get that the spring stretches by 0.05 meters. The initial length of the spring before stretching was 0.240 meters. So the new length of this spring is going to be 0.20 plus the actual stretch, which is 0.05 meters. So we have a final dimension for the length of the spring after stretching, which is 0.29 meters. The other thing they want you to find out in the problem is the energy required to effect the stretch. So we're looking for how much work is done to stretch that distance of 0.05 meters. It's a spring, so the work done is given by 1/2 kx squared. This is 1/2 k happens to be 300 Newton meter. That's the spring constant k. And then the distance that it stretches happens to be 0.05 meters. We have to square that. And so, the one of the meters will cancel out with one of the meters there. And so Newton meter gives you a joule. And so your final answer is 0.375 joules. That's the energy of the work done in stretching the spring. I hope you enjoyed the process. Initially, we wanted to find by how much the spring stretches. We add that to the original length of the spring. That's 0.29 meters. And then on top of that, we want to find the energy used in stretching the spring. So that becomes 1/2 times k, which is 300 Newton per meter, and then times x squared, which is 0.05 meters. Thank you for watching the video. Feel free to share any questions or comments. Okay, bye.